Okay, so here we have 8.10a, adding and subtracting polynomials of degrees 1 and degrees 2. So we're going to compare green apples to red apples. For red apples, I'm going to use apple square as a symbol, and for green apples, I'm going to use a green apple. The red one will be red, green will be green. So let's just say Bob and Joe are at the store and they want to buy red and green apples. Bob wants to buy 4 red apples, and Joe wants to buy 2 green apples. Well, they're both apples, so why are we using 2 different symbols for them? Well, yes, they're both apples, so that's why the base is going to look the same. They're both apples. But red and green are going to be charged differently. Red and green apples are not going to be the same exact thing at a grocery store. Hence why we're using the same base, but different exponents, because they're representing something different. And when we're adding and subtracting, much like in combining like terms, there are different rules that apply as well. So when we're adding and subtracting polynomials and we're using the same variable with different degrees, we can only combine them if they have the same degree. So again, Bob and Joe are at the store. Bob wanted red apples, Joe wanted green apples. Let's break this down individually. What would 4 apples squared look like? Well, if 4 apples squared represents 4 red apples, let's draw 4 red apples. And if 2 apple represents 2 green apples, let's draw 2 green apples. So we get to the cashier, and should the cashier just charge them for 6 total apples? No, they shouldn't, because just like I mentioned earlier, red apples and green apples are 2 totally different things when it comes to pricing, inventory, all that good junk. There's a reason why it's different. They're not apples, but they are different. That's why we can't just simply willy-nilly combine them, adding and subtracting. So Bob and Joe get to the register, but then Bob decides he wants 2 more apples, and Joe decides he'll go ahead and grab 2 more apples. So let's add Bob's 2 more red apples. And let's add Joe's 2 more green apples. Now, let's see what we have in total here. So if Bob started with 4 red apples and he went back and got 2 more red apples, we have what? 6 red apples. 1, 2, 3, 4, 5, 6. Joe did the same thing. He started off with 2 green apples and he went back and grabbed 2 more green apples. He now has 4 green apples. 1, 2, 3, 4. So let's add that into our expression. So again, Bob started off with 4 reds and he went to go grab 2 more reds. So we'll add 2 apples squared. And Joe did the same thing. He started off with 2 but went to go grab 2 more. So we'll add 2 apple. So how else can we represent 6 red apples? We can also represent it as 6 apples squared, right? And the same thing with 4 green apples. We can represent this as 4 apple. So as a new expression, this now can be written as 6 apples squared plus 4 apple. Notice how here on top, when we have 4 apple squared plus another 2 apples squared, that gives us 6 apples squared, right? And then when we have 2 apple plus another 2 apple, 2 plus 2 is 4, so that gives us 4 apple. So let's describe this again, but using algebra tiles this time. So instead of apple squared, I want to use x squared, and instead of apple, I want to use x. We'll use the same numbers to start with. Whenever we first started, we had 4 apple squared plus 2 apple. So let's do 4x squared plus 2x. So we'll bring down 4 x squared tiles and 2 x tiles. Notice here at the bottom, this is generating whatever the algebra tiles are representing, and this is exactly what we're beginning with, 4x squared plus 2x. And then we went in and added 2x squared because Bob wanted 2 more red apples, remember? So let's add in 2 more x squared tiles, just like we did up here in the blue. Now it's giving us 6x squared plus 2x. But then remember, Joe wanted 2 more green apples, and green apples are represented by x. So we're going to add in 2 more x tiles. And that was this expression, this part of the expression up here. So now notice our apple expression is now the same represented in our x's expression. We now have 6x squared, so we have 1, 2, 3, 4, 5, 6 x squared blocks, plus 4x for 1, 2, 3, 4 x blocks. So generally speaking, when we're adding and subtracting again, variables that have a different degree, we can only combine them when they have the similar degree. If they're in different degrees, we cannot combine them. When they're in the same degree, we can combine them. So all of these, x squared had the same degree of 2, and the x's had the same degree of 1. Therefore, all of these apples were able to be combined, and all of these apples were able to be combined.